Hello, this is Lab 8 series resonance. Figure 1 shows the RLC circuit. It has one resistor, one capacitor, and one inductor. And the impedance of this circuit can be written as in equation 1. It's obvious that the impedance is a function of omega. Omega is the frequency of this circuit. When we select omega equals omega 0, which equals 1 over the square root of L times C, the imaginary part of the impedance will be equal to 0. So it only has the real part, that is R. So we call this frequency the resonant frequency. And at this time, we call that the circuit is in resonance. At resonance, Z equals R. The imaginary part equals 0. So the voltage and current are in phase, and the impedance is at a minimum. Therefore, the current is maximum for a given voltage. The transfer function H omega is the ratio between output and input, and it is a function of the frequency. From figure 2, we can see that when we increase the frequency, the magnitude of H starts increase, and when the frequency equals resonant frequency omega 0, the magnitude of H omega reaches 1, and then when we further increase the frequency, the magnitude of H starts decrease. And here we define the lower and upper half power frequencies. These are the frequencies at which the magnitude of transfer function equals 1 over the square root of 2. And also we have the definition for the quality factor and bandwidth. So here is the bandwidth. That is using the upper half power frequency minus the lower half power frequency. In the experiment, we will build the circuit according to figure 3. And here the RL and RC are the equivalent resistance of the inductor and the capacitor. And R0 is a resistor, that's the load. And we build the circuit and do the measurements, and we can use the previous equations to calculate the H max and the resonant frequency and the bandwidth. The second step, we set the function generator to the frequency to be 700 Hz and measure the voltage across the resistor, capacitor, and inductor. The third step is to observe the Lysage's figure. So we connect channel 2 of the oscilloscope to measure the source voltage, and the channel 1 to measure the output voltage, and set the oscilloscope to give channel 2 versus channel 1, so you can observe the Lysage's figure. The fourth step, you need to repeat step 2 and 4 for frequencies 50 Hz apart from 700 Hz to 1200 Hz. That is, you gradually increase the frequency. And what you can see is that the output voltage will increase and decrease. By plotting this curve, you can find the resonant frequency. For the pre-lab questions, you can use the previous equations to solve the pre-lab questions, and the solutions will be discussed in another video. That's all for today's lab. Thank you.